Hey guys, it's Mr. Wigand. Today we're going to look at writing linear equations using point-slope form. So far, most of the time where we've been dealing with linear equations and writing linear equations, we've been using slope-intercept form. Now we're going to look at something new, point-slope form. So point-slope form looks like this. Y minus y1 equals m times the quantity x minus x1. If we look at point-slope form, we see x1 and y1 in red there, and they represent a point on the line. We see m outside the parentheses, and that, as always, represents slope. So basically, that's where the whole name point-slope form is coming from. There's a point, and there's the slope. And with that information, we can write an equation in that form, point-slope form. Alright, so we're going to try and write one now. Write an equation of a line in point-slope form, given a point on the line and the slope. So essentially we're going to use our equation, y minus y1 equals m times the quantity x minus x1. We're going to substitute these coordinates, 3 for x1, 10 for y1, and our slope is 2. We'll substitute that in for m. So y minus y1 is our 10 value equals m, I'm just following this point slope form up here, our slope is 2, times the quantity x minus, and x1 will be the x coordinate 3. And then that's it, that's our equation. It's in point slope form. Now some of you will look at this and feel like it's not complete, and you want to do something, maybe distribute the 2. Maybe you want to try and get y by itself, isolate the variable. But that would be then putting it into slope-intercept form, which we will do sometimes, but right now we just want to leave it here in point-slope form. Alright, let's try another one. Write an equation of a line in point-slope form given 2 points on a line. Before we were given a point and the slope. Now we're given 2 points. Well, we need 1 point and we need the slope. Just like any other time when we had 2 points and we needed to find the slope, we know we can use y2 minus y1 over x2 minus x1. So we're still doing a lot of the things that we've been doing all along. Alright, so my y2, negative 5. Minus y1, 7. My x2, 1. Minus x1, negative 2. Negative 5 minus 7, negative 12. 1 minus negative 2, positive 3. Negative 12 divided by 3, negative 4. So now I have a slope of negative 4, but I have 2 points. I have this negative 2, 7, and 1, negative 5. I only need to use one of them. Well, the interesting thing about point-slope form is it doesn't matter which one I use. I'll still have the correct answer. So I'm going to use this one first. So I'm going to use my point-slope form up here. I'm going to substitute a y value, 7 in for y1. I'll substitute my x value, negative 2, in for x1. And then my slope, I figured, is negative 4. That'll go where my slope is. So y minus my y value, 7, equals my slope, negative 4, times the quantity, x minus my x value, negative 2. I can certainly clean that up and make that x plus 2 if I'd like also. Right, now I'm going to go and use the second point. Y minus, my y value is negative 5, equals m, negative 4, times x minus the quantity, or minus my x value, 1. And now I have 2 equations in point-slope form. Both of them would be correct. And if I actually went through and distributed this negative 4, added 7 to both sides, I would get the same equation in slope-intercept form as if I did the same thing down here. Distributed to negative 4, and then added this negative 5 to both sides. So these, even though they look a little different, they actually are the same equation. Alright, I'm going to give you an opportunity now to try a couple problems. The first problem is write an equation in point slope form given a point and the slope. And that's just like the first example I did. And then write an equation where you're just given 2 points. So at this point you might want to pause and then try these 2 problems on your own. Restart it and see how I do and compare our answers. Alright, first problem. So I have the point 4, 7 and my slope 1/2. I know that this is my point slope form, y minus y1 equals m times the quantity x minus x1. So I'm just substituting in my x and y values for y1 and x1 and my slope for m. Y minus 7, because that's my y value, equals m, 1/2 is my slope, times the quantity x minus my x value is 4. And then bam, that problem is done. Alright, problem number 2. I have 2 points, but I don't have my slope. So let me first find my slope. Alright, slope is y2 minus y1 over x2 minus x1. So that will be negative 8 minus 10 over 2 minus negative 1. Negative 8 minus 10, negative 18. 2 minus negative 1, positive 3. Negative 18 divided by 3, negative 6. So I have a slope of negative 6. I have 2 points. I'm going to use this point first. So y minus my y value is 10 equals my slope, which I just figured out is negative 6, times the quantity x minus my x value is negative 1. Keep in mind I can clean this up and make that x plus 1. Right, that would be my equation in point slope form if I use the first point. If I use this second point, y minus my y value is negative 8 equals m, my slope is negative 6, times the quantity x minus, and my x value is 2. And even though these 2 equations look different, we already talked about that earlier, if I were to distribute the negative 6, add 10 to both sides, do the same thing down here, distribute the negative 6, add negative 8 to both sides, I would get the same equation in slope-intercept form. They just look a little different in point-slope form, but they're the same equation to the same line. Alright, so that's point-slope form. Hopefully now you'll have a better understanding of how to use point-slope form. We've already looked at slope-intercept form, and then after we get comfortable with point-slope form, we'll look at another standard form. Alright, good luck, guys.